They all have a CLI to easily scaffold a project. They all use Babel and Webpack to transpile and bundle your code. They all output to HTML, CSS, and JavaScript when you're done. And they all have a rich ecosystem of plugins. Now, what's really elegant here, whether you choose React, Vue, or Angular, there's no wrong choice. You can build the software that you need using the tools that you enjoy. Now, if you better align with the preferences or with React or Angular or Vue or Svelte or others, then that's the perfect choice for you. Each of these SPA frameworks will give you the power to build thick clients in the browser. So where they differ? Well, they each have different opinions about how you choose to develop these web components that will run as a thick client in the browser. With React, you use JSX that combines JavaScript and HTML together. Now, this may seem a little bit unusual, but it allows you to do separation of concerns on concepts, on business needs, rather than on technologies. By comparison, Angular leverages TypeScript to make IDEs light up really well. So you have excellent tooling and support inside of your designer. By comparison, Vue has single file components where each of the technologies will excel in their own rights. CSS will look like CSS, HTML will look like HTML, and JavaScript or TypeScript looks exactly like you would expect. So my completely biased opinion, Angular, it's kind of built for tooling. So there's a lot of places inside of Angular that are weird just so that it looks right in the tools. Facebook, Facebook is built for, React is built for Facebook size problems. It also has a great slant towards functional things. So if you're at home in Haskell or other functional languages, you'll probably be at home in React. By comparison, Vue, I feel like it's built for developers with a low concept count, with an easy on-ramp. It's a really cool way to get started with single-page applications. As you grab these slides from robrich.org, you can click on each of these blue links to learn more about these particular topics. So here is a detailed comparison of all of the frameworks where you can dig in more to the difference between Vue, Angular, and React. So let's start by creating a Vue app. Now I've spun up a console here and I said, Vue, create a new app. Now, when I get this, I'm asked to pick whether I want Vue version 2 or 3, or I can manually select features. Let's do that. So I'll choose a Vue version. I'll choose Babel support. I'll enable TypeScript. I'll enable progressive web app. I can enable Vue router. I can enable Vuex, the Flux store associated with Vue. I can enable CSS preprocessors like Sass or Less, a linter and a formatter, unit testing using Mocha or Jest, and end-to-end testing using Cypress or another library. Once I've made those choices, now it'll start to interview me to identify those specific needs that I need. I'll choose Vue 2 in this case because it's most compatible. Do I want to use class style components? I do not. Yes, I want to use Babel along. And so you can see how it's going to interview us and build up a website that will have all of the features that we specifically need. The last question that it asks, do we want to save this as a template where we can just pick it from the list at the beginning, like we did in the Vue 2 or Vue 3 question? So once we've got this website up in place, we have this website that starts here. Main.js will give us the details that we need to start up our website. Or in this case, because I chose TypeScript, main.ts will get us our basic website. Now that we've got our basic website, we can flip over to, actually here, we will say npm run serve, and it will do all of the compilation that it needs to, and ultimately start our application, in this case on localhost 8080. So here's our website. Now with the default website, because we choose Vue router, we get two different pages. Notice how it changes the URL here, not just the hash. That's the option that we chose. Now we've got these two pages. They're both in TypeScript. Now let's dig in and take a look at what we can do here. We've got Vue set up. Vue is a really elegant mechanism for enabling developers to dig into creating single-page applications. Let's look as well at TypeScript. Why would I choose TypeScript? TypeScript is great at identifying, did I call it correctly? Here's some code that I found in a sample project. I call some critical function. And here in this critical function, I'm going to pass in a customer and an invoice and a date. Why do I need to pass in true as an object? What does true mean? And what is false? What is 6? Are these 2 commas in the correct spot? Was this a typo, or did I really mean to pass undefined in here? I don't know. And that's what TypeScript is meant to solve. It gives us syntax highlighting inside of our editor so that we can know if we called it correctly. One way that we've compensated for this in the past is to pass in an object. So here's an object, and now with this object, I have named parameters. This config value now is all of the configuration details that I need: the date, the invoice, the customer. I know what each of these arguments are now, and I don't need to put those arguments in the correct order. But did I catch all the arguments? Did I pass in each one? Is this config object the right shape? Have I passed in enough configuration details? I still don't know. And thus TypeScript. Here's another great example. In jQuery, I said $.foo, I selected foo, and then it did .ajax. Should I do Ajax on a DOM element, or should I do it just on the $? I don't know. And that's where TypeScript will help us. It will help us find those common syntax errors and help us fix it really quickly. Now, the cool thing about TypeScript is it is a superset of JavaScript. If you have JavaScript, it is valid TypeScript. It adds optional type hints at design time so that you can get this extra syntax highlighting if you choose to enable it. At the end of the day, though, it doesn't validate or restrict the behavior. The content that's running in the browser is JavaScript. Now, we might have a source map back to the original TypeScript that created it, but what's running and debugging in the browser is JavaScript. So as we cast things into, for example, a TypeScript interface, we're not removing properties like we would in Java. Rather, we just validate at design time that we think these properties will probably exist on this interface. And we can get red squiggles if they don't. TypeScript is free and open source, and you can download it from NPM. So why would I choose TypeScript? TypeScript, like Babel, allows me to use new features before they're publicly available in browsers. And like Babel, it will transpile this content down into the version that is compatible with the browser. So for example, the nullish coalescing operator, the 2 question marks, came to TypeScript before it came to browsers. Optional chaining with the question mark dot, that came to TypeScript as well before it came to browsers. Now, the beauty is both of these features are in all evergreen browsers now, and so we don't need TypeScript to rewrite these into other things. We can just use this in place. TypeScript is great for being able to let us use new features in addition to helping us find bugs. TypeScript will validate that the types match, but TypeScript doesn't validate your business logic. Now, if you want to validate your business logic, you'll need unit tests to do that. So if you believe that TypeScript is your one and only unit test, if it compiles, it builds, you should probably avoid TypeScript. It's going to be a crutch. So how do I get started with TypeScript? Well, the first step is to get the TypeScript compiler in place, the TSC, and a lot of the SPA templates will automatically put that in place. So if I'm using Create React App or the Vue CLI or the Angular CLI, I'll already have the TypeScript compiler and the TS config in place. At that point, I can just rename my file. So I'm going to rename it from .js to .ts, and now it's a TypeScript file. The TypeScript compiler will look at this file and validate whatever it can. I don't need to change any logic if I don't want to. But once I have this TypeScript file, I can choose to optionally add these type hints. So here's a name, and I've made it a string type. I'm also going to return a string from this function. So now I know that name will be a string because I've chosen to enforce it that way. Well, technically, I'm not enforcing it. Rather, This is a hint. So if somebody passes in an object, my code will continue to work. At runtime, it runs JavaScript, not TypeScript. But in my IDE, I can get a red squiggle. I don't think you meant to pass an object in here. It's expecting a string. That's perfect. Now let's level up again and take a look at how we might include other things in TypeScript. So I start with this JavaScript file, or maybe it's a TypeScript file, and I just have const x, a is b, and c is d. Is that right? I don't know. Let's add some optional type hints to be able to explain this a little bit better and help us infer inside of our design environment if we've called it correctly. So I'm going to create inside a different file this interface, this customer info interface. Now here in the customer info interface, I can define A as a string, C as a number, O as a string. And notice this question mark here. I'm specifically saying this is optional. So if you only have an A and a C, it's still okay. Already we have more information. We know that this is about a customer. Now I'm going to choose to import this file from my types.ts file. Now I have the customer info. Now this is only at design time. At compile time, this customer info reference will get completely removed. We're not increasing the bundle size. But now I'm saying const x is of type customer info. I've said it should have this shape. It should have A as a string, C as a number, O optionally as a string. So if I have extra properties, or if I don't have enough properties, then it will give me red squiggles to help me understand that those aren't quite correct. So in this case, I get the red squiggles by the C variable. It expects this to be a number. And in this case, I passed in a string. I love it when TypeScript helps me find those typos as I'm coding. TypeScript. Now, TypeScript will give us the types that it can figure out by itself, and that's wonderful. But whenever you can, annotate your methods, both the input parameters and the return types, each of the variables that you declare, annotate those with the types, because now you've made your intent very clear. The cool part about making your intent very clear is that when someone comes behind you to maintain this code, then they'll understand it as well. I'm usually that person. I'm following on behind the code that I wrote shortly after I forgot what I did. So creating clues, creating these breadcrumbs for me is really powerful. So we've got Vue and we've got TypeScript. Vue is a really elegant mechanism for getting started with single page applications really quickly. And TypeScript will help me find typos in my code. What happens when we put them together? Well, let's do that. Here in the code, each of these folders, step 0, step 1, step 2, will represent a step that we look at as we go through. Now, each of those then will allow us to level up in our TypeScript content. As you grab this code, grab it from robrich.org, you can npm install in each directory, or in my case, I'm going to copy the content into a demo directory so that we can get started there. So here's that demo directory, and I'm just going to keep filling this demo directory with the latest copy. Now that I've got that in place, here's the website that we've got booted up. Now, we are running JavaScript in the browser. Looking at the sources, we can see that here is JavaScript, but we've got it wired up through TypeScript, and so we have some source maps, which is really helpful. In this case, we don't have any errors in our content, but we've got some ESLint fails. I kind of like to have semicolons at the end of my lines. I grant that JavaScript can auto-insert those, but I just want to be a little bit more explicit. So let's go into step 1, where we fix all of our ESLint fails. And now we have all of the semicolons in place. Perfect. Now this Vue app is great. Main.ts will get us started, and we'll wire up both the router and the store, the router to handle URLs, and the Flux store. Well, the router then explains, the router will wire up, or here's the router. The router will wire up various URLs. So if the path is /, it'll go with the home component. If the path is about, it'll go to the about component. In the home component, I just have the normal pieces. Now we get to see the Vue's single file components. here's a template. Now this is HTML, where HTML excels. Here's our JavaScript. In this case, we've said lang equals TS, and now it's TypeScript. So here's the TypeScript. We'll import our component, we'll export our class, and everything works great. Inside of our component, we're referencing this hello world component, and we're passing in a parameter to that component. Now we get to see the single file components really well as well. Here's all of the content that we have in our hello world component, and we are defining our component this way so that TypeScript can inspect that configuration. We also have CSS here. We've chosen to add scoped so that this CSS is only scoped to this component and down. It will start to rewrite these classes with randomly generated names so that as we use them here inside of our items, then these styles won't leak into other spots. Okay, so we've got our system. It's working out pretty well. And I want to add Viewify. Now, Viewify is a library that was built and works great with Vue, but it wasn't designed with TypeScript in mind. So let's add Viewify, and that will get our content into place. Let's go grab step 2. Oh, not step 2. Step 2, Viewify. There we go. And we'll copy that into the demo folder. Now that we've got our demo file in place, and I may be racing the compiler here as it grabs the Viewify content, we can take a look at the pieces that we have. Now, Viewify has overridden our home component. Actually, I may have done bad things here. Let's see. Nope, it looks like we're good. Viewify has overridden our home component to add some additional content, our app.vue, and now we're using vapp and vapp to be able to pull in those bootstrap themes. Now, the cool part about this is that we've got our site. I am racing the compiler in this case. The bummer part, though, is, well, TypeScript knows nothing about Viewify. Now, our site still works. The JavaScript still works, but we're getting errors in our TypeScript compiler. Here's that error. I don't know what Viewify is. Okay, so let's head off to the web. Let's Google how do we get Viewify set in place. And it looks like if we add Viewify/types, and in the type section we add Viewify, then we'll be able to power it into place. Okay, let's do that. Let's add these pieces. And now with these pieces here in place in the TS config, now we have Viewify working as expected. So here's an additional reference of Viewify. We also have this reference of Viewify. And now here in our main.ts, then TypeScript understands what is Viewify. Now that was kind of an unusual circumstance, but now here inside of our app, we've got it compiling correctly. And if we refresh, oh, actually, I do need to restart the compiler here because we did change our TS config. Now, once I build this, it will go through and validate all of the pieces, pull in all of the Viewify libraries, and inspect all of those details. Now, if we're using something like Vite, then we won't do all the TypeScript validation here. We'll just launch the browser really fast. Vite is really fun. But here with just a regular Vue app, then we'll go build all of our modules. I love how it counts up both sides as it discovers more modules that it needs to include. And eventually we'll get Viewify in place. This is awesome. Go, 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 go. Almost there, almost there. We're close. Viewify is coming into place. Okay. 841 out of 842. There we go. Now our server is ready to go, and let's push refresh, and we can see what Viewify has given us. We have all of these bootstrap themes. That's perfect. Now, I did put the Vue logo here on the About page just so we can see it. but that Bootstrap theme is looking nice. Okay, so let's build some components. I want to build a hello world component. So let's go grab some components. And here in our app, I will build this counter component. Now, a counter component is really fun, where we just output the current count. We'll use our curly braces, our handlebars syntax. Here we can talk about how to push buttons. So this view button that we got from Viewify, so it'll be styled nicely. When we click it, thus the @ for click, we will call the add method. When we click this one, we'll call the subtract method, and that will adjust our count. Here in our object, in our view component, we can set our count. It's currently set at 0. And now we can add content. So we'll add a count here, and we'll subtract the count here. And if we refresh our page, here's our playground page, we can see that that component works just fine. Now this is our component, this box right here, but I've chosen to publish the event to others. So here I'm emitting this event so that our host page can listen for it. Now here's our host page, and we're going to import that counter component. We will list it as our component so the compiler knows how to find it. And here we will listen for this count changed event. Now when this count changed event happens, we will go grab this. Here's our count changed event. We expect a count to come in, and we will set our count. Now in this case, I made a mistake. I told it that the count property was a string. I have a string here, I have a string here, but as we can see inside of our counter component, this is a number. What runs in the browser is JavaScript. So it works just fine. Now, the interesting thing here is that TypeScript wasn't able to infer these properties between components. In Vue 3, this gets better, but this might be one place where TypeScript really doesn't help you in a great way. You'll probably want to lean on unit tests to validate your integrations between components. So we built a great component, and we can see the single page components where we have our template, our HTML, we have our script with our TypeScript, and we have our CSS, in this case, scoped to this component. Let's add some more components. I'm going to add a bunch of components, grabbing things from, for example, Font Awesome and a bunch of other places. Let's refresh this page. I bet we're racing the compiler here. Here we go. So here's some Font Awesome components. We've got this navigator component. Let's take a look at each of those components. Here in our playground page, we just import each of those components and then set them in place in our page. So the icon playground component, we're just grabbing vicon from Viewify. And the navigator component, we're testing that we can navigate both just by specifying a URL. And also we can navigate programmatically by calling $router.push. And we can. Let's link this way, come back to our playground, and link this way. Perfect. Now, what's really cool is that TypeScript understands that Vue is going to have a $router property on it. So TypeScript is completely fine with this. It understands how Vue works. Both Vuex and Vue router, all of these are just built in the places that we need them. They're built in based on this shims. So we have some shims that allow us to do some interesting things. So we've got our components and everything is going well. Cruising through the Viewify website, I enjoyed this component. Here's a form component. I like this. I can fill in some content. If it's required, it will highlight that. And once I fill it in, then it will allow me to select this validate button. And that will submit the form. I like it. Let's switch over to the code. Here's our HTML. Here's our JavaScript that we need. Now, Viewify was created without TypeScript in mind. So as we go grab this content, we'll see that, well, it works, but it's weird. Okay, so here's our form component. We've got the HTML in place, and We've got the functions for validation in place, and we've got our component, and we can come back in here and refresh our page. And here's our form. It works. If I'm not specifying the data, then it's invalid. If I do specify it, then eventually, once I've checked all of the things, my form is valid, and I can choose to submit it. But here in TypeScript, well, we're getting some errors on this, the .validate method. TypeScript doesn't know what this .refs.form is, and so it doesn't know that it has a validate method on it. How can we solve this? Well, let's create a computed property. I'm going to create a computed here, and we'll give it a comma here. Let's say this is form. And how do I do form? I'm going to return this $refs.form as HTML form control. Now I know specifically that this is an HTML form control. And so if I say $.form, then it has a specific validate property on it. I don't think it's HTML form element. There we go. Now we know that it has a validate property on it. So let's switch all three of these methods over to it. And now we get TypeScript to be happy. Now, in this case, we've chosen this as property. This says, hey, TypeScript, I know that I'm right. Don't validate it. Take my word for it. That's kind of a brute force approach, but we can understand why this will be a great solution in this case. Let's actually take it a little bit farther, though, and look at how we might abstract this out a little bit farther. So here in step 7, we have this form, and we're saying it is of type vForm. I'm going to return, I'm casting it as vForm and returning it so that we get all of these pieces. Scrolling up a little bit, we can see where we import vForm from types. Okay, we've built this types file over here that will just say, hey, a vForm is an HTML form element, and it's a component, and it has these 3 methods that behave in this way. In this case, validate returns a Boolean, reset returns nothing, and reset validation returns nothing. Now that I've very specifically defined how I want this type to work, I can cast my ref into this property. And now TypeScript specifically knows what this form can do. Now with this computed member, I was able to take that thing that was, well, kind of unknown and turn it into something that is very well known. Really nice. Okay, so we've got the type declaration in place. Now, one thing that I noticed here in this is that when I refresh the page, it always starts with 0. I would like it to start with a random number. So let's pop open Lodash and let's look for random. And here in the random function, we can see that random will take in a lower and an upper and automatically build a thing. Okay, so let's do that. I'm going to come into my counter component and I'm going to import random from Lodash. And I will call random. Let's say random 0 and 100. Now, we know nothing about this Lodash library. Okay, let's use a different technique, a new technique. Let's create a new file and let's create a lodash.d.ts file. Now, this is a type declaration file. Unlike here, where we're just defining an interface, we're going to define how this module works. Okay, so let's say declare module Lodash. And in this Lodash module, we can say export function random. And this will take in a min, which is a number, and a max, which is also a number. And it will return a number. This type declaration file, we could think of this kind of like a C header file, defines what this Lodash library can do. Now, Lodash was built with JavaScript without TypeScript in mind. And so now that we have this in place, if we restart Visual Studio or VS Code, then we can get that type declaration to take effect. So let's pop open this again, restarting that VS Code, the TypeScript compiler. And now we'll get to see that it understands what Lodash is. We no longer have the red squiggle. And since we've defined this random function, we now understand how random works. So if I put in foo, it's like, hey, that's not a number. Yeah, once the TypeScript compiler pops up and finds it. That's not a number, we'll get the red squiggles. Let's set this back to 100, a number, and we've got it. Now, that was kind of intense to be able to create this Lodash module. And we only created it for one function. But there's a lot of functions here in Lodash. If we take a look at this content, there's, well, a lot of functions. And we didn't account for the fact that it has this floating one that is optional and upper is optional. It'd take a lot to build up all of the details of this library. Let's flip over to Definitely Typed, where the community has come together to be able to document the TypeScript type declarations for a lot of open source libraries. You can see that there's 6,500 TypeScript libraries to find here. Each of these is the TypeScript declaration file for that library. Now, a library could choose to create TypeScript declaration files on its own as well. That's completely fine. Or they can publish them here. Each of these packages is published to NPM in the types namespace. So I'll do a search for at types/Lodash, and I'll land on this page right here. And I can say npm install --save. In this case, I will do --save-dev at type/Lodash. Here's our next technique. We'll go grab the type declarations from the community to pull in all of those type declarations for our library. Now, the cool thing about this type declaration file is it will now include all of the pieces that we need. And we notice here in our counter component, we didn't reference it. The TypeScript compiler will automatically discover all of the .d.ts files and include those type declarations. Now, if we want a specific type, we can do this where we create a type. But the cool part about type declaration files is they'll just take effect. That's cool. So we've got this type declaration file, and let's actually, I think we've, that will pull in one. Let's pull in the type declaration file. Oh, step 8. I live coded that one instead. Let's also pull in 9, where we've got the Lodash type declaration file. And we can see now this Lodash type declaration file has those pieces. Now, if I chose, I could say npm install save dev at types/Lodash, and I would get all of the type declarations from Definitely Typed. Now, in this case, I didn't do that so that I could show you a type declaration file. But once I did that, then I could delete this lodash.d.ts file. Okay, so I'm building this site. I really like how this is working. And now when I refresh, I get a random number and it still works. It does all of the things. I did notice that when I first refreshed, it didn't publish that event straight away. Sounds like here in my component, I need to do a method on mounted to be able to fire that event as well. I'll leave that to the reader. Okay, so I like how this site is turning out so far. I would like to do a parallax effect. So let's head out to Vue Awesome. If you search for awesome and your library, you'll probably land on a GitHub repo, not that unlike this. Here's a curated list of really awesome components. Now we can take a look through resources, projects, and then components where we're looking at the component types. Wow, there's a lot of them. Once we get into the components themselves, then we can see each of these libraries and we can look at really interesting things. Well, I'm after Parallax. So let's go into the Parallax section. And I chose Vue Parallax Js. Now, here in the Vue Parallax Js library, we've got this library, and it was definitely not built with TypeScript in mind. So how are these types working? Well, let's take a look at the source code. Here's the Vue Parallax JS library. And okay, I've got this prototype, and I've got remove, add. What is EL and what is binding? Apparently, it's referencing this window object. I'm not quite sure how this is working. Ooh, export default. Maybe this will help me identify the plugins that I need. Okay, so I've got this install. It takes in, that looks like a Vue instance, and then OS, is that operating system or options? Okay, so it's kind of looking through those options maybe. So I'm going to pull in this Parallax library. And now with this Parallax library in place, we can flip back to our code and we can see that, well, once again, Vue knows nothing, or TypeScript knows nothing about how Parallax works. Creating a type declaration could be possible, but I really want some help. Okay, let's head over to the Stack Overflow article that talks about generating type declaration files. We can use the TypeScript compiler, TSC. We can pass in the -- declaration argument, and we can reference any TypeScript file. Okay, let's head out into that Parallax library. Here we are. And let's take a look at this Vue Parallax es.js. I believe that's the file that we're referencing. Let's go double check. Vue Parallax -js.js. Okay, so I want to turn this into a TypeScript declaration file. Well, first thing, I will need to copy it into a .ts file. TypeScript compiles TypeScript files. And so now that I have this as a TypeScript file, I can say tsc -- declaration, and I can give it this TypeScript file. Okay, I've now built this TypeScript declaration file, and it's probably not great, but we can take a look at it. We've got a lot of errors there, but that'll definitely get us started. Let's open up this folder inside of VS Code, and we can take a look at the TypeScript declaration file that it built for us. Here's that .d.ts file. It's got some any's and voids, but we can get started. That will help us get started with our type declaration file. Now, it may not be perfect, but it will get us on our way. I'm going to delete this file, and I'm going to delete this file just so that it doesn't, the TypeScript compiler doesn't get confused. And let's go pull in the file that I was able to craft here. So this one is step 11. And with step 11, ooh, my machine's having fun compiling that one. With step 11, let me actually close this Vue instance just in case. I now have this Vue Parallax.d.ts. So I was able to look at both the type declaration that it generated together with other plugins and kind of build up this mechanism where I've got this Vue Parallax options and I've got this plugin object of type there. And so now if I pop open main.ts, I can see that Vue Parallax JS comes in just fine. I can say Vue.use that, and it works great. Now, I'm probably racing the compiler here. Let's go double check. Yep, I got lots of errors, but I bet that all solved itself. So let's come back in here to our app. And if I come here to the home page, we now see the parallax effect. This one is moving a lot faster than this one. That's perfect. Now it looks like I have some column issues where I want this one to be over here, but that's totally fine. We have this parallax effect working well, and we were able to get it to work correctly inside TypeScript here with this type declaration file. So let's take a look at each of the techniques that we looked at in ways to make JavaScript libraries work inside of TypeScript. Now, this isn't the order that we discovered it in, but this is probably the order that you want to use them in. First, use libraries built in TypeScript. Now, you're probably picking your library for the features it has, not for the language it was built in. So all else being equal, if it's written in TypeScript, that's great, but you'll probably want to choose the library you want. Okay, next up, as you install your library, install types/your library. It may exist, it may not, but if it exists, you've got the type declarations either from the author or from the community, and you're good to go. Next, you can create a handcrafted type declaration file. We built this for Lodash, where we built the random function. If you handcraft your type declaration file, you may choose to contribute it back to definitely typed as well. Next, if the type declaration file is overly complex or you're having difficulty discovering it, then move your JS file to a TS file and use tsc-declaration to auto-generate a type declaration file. It probably won't be perfect, but it'll probably be pretty close, and that'll get you started. Next, you can use as. Now, we used as to say, hey, TypeScript, I know better. Use this sparingly, and even more sparingly, any. Any is a unique type inside of TypeScript where it says, hey, I don't know what it's doing. Just let it be okay. TypeScript will ignore all of the things on anything declared as type any and just let you do whatever you need to. This is great if you have a particularly difficult library that it just doesn't function correctly and you can't figure out the declaration. Now, the hard part about any, though, is you basically told TypeScript to ignore this. TypeScript isn't helping anymore. So there's a way that you can flag any's with an ESLint rule and not allow them in your code base. Another technique is you can create a @TSIgnore comment. Now, this comment will just tell TypeScript the next line is okay, and you don't need to re-enable it. And this can be a great way to get past that problematic file or declaration. Now, the hard part is you've told TypeScript specifically to ignore this line. It won't check it. So you can also create an ESLint rule to ignore these TSIgnore comments, or to not allow TSIgnore comments. So we've created a bunch of mechanisms where we can include JavaScript libraries in TypeScript. When to use Vue and TypeScript together? If you have a large or long-lived code base, having these additional checks will be helpful in reducing risk if you want to mercilessly refactor. It's great for communicating between developers because you're able to express your intent much more expressively than with just plain JavaScript. You can say, I expect you to pass in a string, rather than just anything. It's a good default go-to for a first syntax check, but you definitely want to avoid TypeScript if you presume that that's going to be the only check. If you depend on lots of components that weren't written in TypeScript, then you may spend a lot of time creating these type declaration files. It may be easier just to flip to regular JavaScript where type declaration files aren't necessary. Now, you lose the benefit of type checking, but you don't need to create these declaration files. Vue 3 is written in TypeScript, so the Vue community is moving towards TypeScript in many places. So this is probably not as big a concern the more modern you get. For quick doodles, or if you're not using the CLI to generate your Vue project, then you can't use TypeScript. You don't have a compiler there. So quick doodles are probably best just in JavaScript. If you believe that TypeScript is your only unit test, then TypeScript is definitely not for you. You still need a good suite of both unit and integration tests to validate that your system is working correctly. TypeScript will validate that you don't have syntax errors. It will not validate logic errors. Use unit tests for that. Chris Fritz is on the Vue team and has some thoughts on this as well. grab these slides from robrich.org and click through to learn his thoughts. He created the Vue Enterprise boilerplate, and spoiler, it's not in TypeScript. This has been a lot of fun being able to show you how Vue and TypeScript can work really well together to build thick client single-page applications. If you're watching this live, you can ask me questions here in chat. If you're watching this as a pre-recorded thing later, then hit me up on Twitter. And you can, as always, grab the slides and code live right now at robrich.org. This has been so much fun getting to show you Vue and TypeScript. For those of you who are here live, what are your questions? What are your thoughts? What TypeScript methodologies do you use to pull in problematic JavaScript libraries?
Oh, nice. That was an amazing presentation, Rob. Hello, Rob. How are you?
Doing well. How are you?
I'm fine as well. I'm just trying to fix my issue with my internet, but anything else, it looks great. So first, thank you for your time. There's a terrible time to internet. I guess a lot of people are watching you because my internet connection is not good enough. So there are two questions that we have a couple minutes to answer. So the first one is
definitely.
about you'd be the umbrella name for all tests presented. They neither fall into unit tests nor end-to-end tests.
I can't hear you very well. Can you ask me again?
Yes. So you'd be the umbrella name for all the tests presented.
Mm-hmm.
They neither fall into unit tests nor end-to-end tests.
Right. Yeah, testing is quite an expansive system. And I love that the Vue CLI will scaffold both. I think in this case, I didn't do the tests, but we saw at the beginning how in the CLI, we can pick both unit tests and end-to-end tests. And then once you pick one, in the unit test category, it will let you pick between Mocha and Chai or Jest. And in the end-to-end test, it will allow you to pick Cypress or Nightwatch. And the cool part then is you can dial out each of those pieces. What's really cool is both in Mocha and Chai or in Jest and in Cypress, you can use TypeScript there as well. Now, you will need a TS config that terminates in that folder, but it's really beautiful in that you can create a nested TS config where rather than specifying all of these options, you can just say, I'll create a new one. Let's create a new folder, tests. And here I can add a new folder, unit. And then inside of here, I'll create a new file, tsconfig.json. And this tsconfig can be really simple. It can just say extends ... tsconfig.json. Now, the beauty here is that you've just rigged up your unit tests to compile in TypeScript as well. And then you can override it with the additional type declarations that you need, pulling in the Jest libraries or the Cypress libraries. But now you've got your testing being set up in TypeScript as well. Now here in package.json, we're using the Vue CLI to run the TypeScript compiler. But inside your tests, you may need to run TSC specifically to go grab the TypeScript compile. What I love, though, about the Vue CLI is that it's able to run the TypeScript compiler based on your configuration, and it auto-discovers that piece. So if you use the Vue CLI to set up your project, then it will have these entries in to automatically rebuild your tests in TypeScript and then run them in the ways that they need to as well. Unit testing with TypeScript is really cool.
Yes. So thank you, Rob. Unfortunately, you need to end here because we have the keynote. And hopefully see you around. See you soon in health and physically.
That sounds great. I'm looking forward to the keynote. I'll see you there.
See you there. Bye.